Hi there, welcome to another video of CodeRash with Gaurav. With this video, we are starting our journey of solving coding related exercises or the machine coding round interview questions which are often asked and which are very popular during the interview rounds of many companies. So we'll be looking at what are these problems, we'll try to code for it, and we'll also see what can be the time complexity of the solution that we are writing. So stay tuned and let's begin. In this video, we are going to look at Pascal's triangle. This is a very popular question which is often asked in JavaScript, React or front-end interviews. So let us see what is a Pascal's triangle and in what format this question will be given to you. So the interviewer will be asking you to implement a React component that displays Pascal's triangle for the given number of rows. And the interviewer will also show you how a Pascal's triangles look like. So you can see a pattern here. And at this point, the interviewer may or may not be interested in telling you what is the pattern, because the interviewer may want you to figure out what is the pattern. So provided a given number of rows, let's say rows is 5, you should be able to print the Pascal's triangle for 5 rows. Let's say 1, 2, 3, 4 and 5. So up to this point, the Pascal's triangle should be printed as a React component. Now let us see and understand what is the pattern and what is the logic behind generating Pascal's triangle. So in mathematics, Pascal's triangle is a triangular array of binomial coefficients that often comes in the probability theory, combinatorics and algebra. So if you look at this Pascal's triangle, all the values on the left are filled with 1. Also on the right they are filled with 1. And there is a special logic of generating the values that are coming in between, which is basically nothing but each and every value is the sum of the values above it. So if you look at this 2, this would have been a sum of 1 plus 1, 3 is a sum of 1 plus 2, similarly this 3 is a sum of 2 plus 1. Here also, if we look at the logic, this guy will be generated using 1 plus 3, so we get 4. And this logic will continue for rest of the rows. So at any given index, if you want to calculate the value of that index, it will be the values above it. You need to sum the value on the left on value on the right in the row above it and you get the value. So this is how a Pascal's triangle is generated. Let us also see in brief what is the history of Pascal's triangle. Often in Western world, it is known after the French mathematician Blaise Pascal. But it is good to know that this particular theorem or this particular formula was known to Indian scientists much before that. So scientists like Pingala, Vahra Mihira and Halayuda, these guys have detailed and given a formula for generating Pascal's triangle way back. Now given the fact that we know how a Pascal's triangle look like and what is the formula for generating that, let us get into code and implement this. To give us a head start, I have already bootstrapped this project where I am able to watch on the files. If I do something, I'll be able to immediately reflect that in the browser. So I've done this using white as a build tool. In some other video, we'll cover this topic as well, where how can you very quickly get started with React and your dev setup with a browser ready, so that you just save your changes and it immediately reflects the browser. So to begin with, let me walk you through the folder structure that I've created. We begin with index.html. Index.html points to a module which is called as app.jsx. From app.jsx, we are just rendering a component which is Pascal's triangle. So this is going to be the answer to the question that we are solving. And the Pascal's triangle takes as a prop the number of rows which you want to render for this triangle. And it just renders that in the root. So this is going to be the React component that we are going to write in Pascal's triangle. For now, I have just added a dummy div which says insert Pascal triangle of these many rows here. So if I just do some changes here, I should be able to immediately see that reflecting in the browser. So we are good to go. And most of the logic will not be written in the component will be using just for rendering purpose. We will be writing our logic of generating the triangle in the function which is called as triangle generator. So we are writing a method over here which is called as get Pascal's triangle, and this guy is going to return us the array of rows, and that we are going to use to render the data. Before beginning to solve and code this problem, let us first see and analyze the problem better if there are patterns and there is some information that we can find out from the problem itself. So if you look at the problem closely, if you look at this triangle, each and every row, the row number is the number of elements in that row itself. So if you look at the fourth row, let's say, the fourth row has four number of elements. Similarly, for any row. So this gives us a pattern that we can create a kind of skeleton first, and in that skeleton, we can pre-fill the ones on the left and ones on the right, so that we create a triangular structure where we start with one, we keep some kind of a holes in between, and then the last element we fill with one. So this kind of a triangular skeleton we can create first, so that a part of our problem is already solved. And then for rest of the holes that we are creating out of in this skeleton, we will try to solve the problem only for that. And there we'll use the Pascal's formula. So let us begin. And also, if you look at the first two rows, there is no logic to implement here. Like if you want to calculate the value for this particular index, there is no left index in the row above. So with this fact, we can pre-fill the first two rows in our solution. So let's begin. So let's say we have the final array created as a 2D array, and the first row has just one number, and the next row, the second row, has two elements, 1 and 1. Now with this two rows created, let us try to create further rows. So let's have I, let I equals to, let's start with the third row for which the index is going to be 2. So let's say I less than, we are going to go till the rows and I plus plus. Now for the given row, we are going to have ARR of I. Let us create a new array, a blank array, and let us use the row number itself as the number of elements that can be present in that row. So let us use I plus 1, because I is the index and we want the length of that row. We are going to increment that with 1. Now at this point, let us log what we got. So let us see what we got. So I'm going to say node triangle generator. Let's see, we got an error, unexpected token export. Okay, so for now, to run this in node, let us just call this function directly with, let's say, 5 rows, and let's run this again. Okay, so we got the first rows pre-filled, which we had in the solution itself, and in the third row we are getting 3 empty items, fourth row 4 empty items, and similarly for the fifth row. So this creates a kind of a pre-filled array structure for us, and this creates a like a triangular format of the array. And because of the fact that the first and the last element is always going to be 1, let us do that. So ARR of I, wherever you are, the first item, and ARR of I, the last item, which will be I in this case. Let us initialize that with 1. Let's see what we got. So we if we talk about the third row, we are getting first element as 1, the last element as 1, and 1 empty hole created. Similarly for the second row, 2 holes created and 3 holes created for the third row. Now in the last row, which is the row number 5, we have 5 elements, 1 and 1 pre-filled on the left and right, and 3 empty items created for us. So now our problem statement remains only about these empty items which we want to fill. Now that we have a skeleton created with holes, let us try to fill these holes. Start with a row and we'll go into the columns and try to fill those values. So let's start with row. The first and second row are pre-filled here. So let us start with the third row, and which will be having the index as 2. Row less than the rows that we are getting, and row plus plus. And let us go through the columns. So for let columns, let's say col equals to, and here also for the first column we already know that it is going to be 1, so no special computation over there. Let us start with the index of column equals to 1, which is the second column. So column less than the row, because the number of elements in a row are the row number itself. Let us say column plus plus, and this is where we should be filling our the row and the column value. This is what we want to compute. Now using the formula from the triangle that we had, let us try to reuse the values of the previous row. So let us have the previous row taken out in a variable. Let us say previous row equals to array of the row minus 1. Like wherever you are, take the row above that. So what we should be doing over here is previous row of column minus 1 plus previous row of column. Now let us understand this better. Let us take this particular element as an example. So you are trying to fill the value of index 1. Now let us see what all indexes from the row above I'll be adding. So I'll be adding index number 0 and index number 1. So I want to fill the value of index 1. So I am going to take 0 and 1. So index minus 1 and the index itself. Let us see if that logic applies for this index also. I am going to fill in the value for index which is 2. So I'll be using index number 1 and index number 2 from the previous row. So index and basically index and index minus 1. So we are going to use these two indices from the row above to get the value of the current column. So let us try to validate this and let us log what we got. Let us run this. Okay, so we have been printing for rows, 5 rows. We got 1 1 1 1 2 1 1 3 3 1 1 4 6 4 1. Let us see in the 5th row what do we have. We have 1 4 6 4 1. Let us see for more of such rows. Let us print for 7 rows at least and validate that if our logic is correct. So for row number 6 we get 1 5 10 10 5. So let us see 1 5 10 10 5 1, which is good, and we get 1 6 15 20 and then 15 6 1. 1 6 15 20 15 6 1. Perfect. So this guy generates our Pascal triangle perfectly, and this 2D array is created. Now using this 2D array, we just need to render this properly in a React component in a triangular format. That will be the second half of the problem. So you have already created a Pascal's triangle in terms of an array. Now let us use this. Let us use this data component, that data part, in the renderer, and let's print it out. Now to use this Pascal's triangle data generated, let us remove the temporary logic that we added of calling this function from here itself. Let us export this function and also return this particular array from here. We should be able to return the array that we just generated, and this we are going to use in the Pascal's triangle component. Import get Pascal's triangle. This function we are going to use. So let us have our data prepared equals to get Pascal's triangle. I'm going to pass on the same number of rows which I am getting in the component to the get Pascal's triangle function. So now that we have our data, let us get rid of this guy. Let us call this with a special class name because we also want to do styling later. Let us call this guy as a container, and here we are going to do something with our data. Let us say data dot map. Let us go through each and every entry. We are getting rows here, and for each and every row let us return a div which is just going to list down the current row to begin with. So in this div we are going to just say a row. So let us see if this works. We get 1 1 1 1 2 1. Okay, so the our triangle is printed over here. Basically the data that we got, we have just printed that as is. So let us have this class name as a row, and let us have within this row, let us have row dot map. Let us go through each and every row. We are getting columns here, and let us return a span from here. Let's say span, and within this span we are going to use the column because we want to have all the values of a row within one line. So let us have this class name as column so that we can style it better later on. Now let's save this guy and let's see what are we getting. We should be getting rows and columns now. Okay, so we are getting divs created for all the rows and columns created and spans created for the columns. Let us validate this. So let us look at the element structure. We are getting all the rows. We have a container created, and then we have all the rows listed down, and for each and every row we are getting columns created. Perfect. So now let us try to style this better. We are already importing the styles.css, which is empty for now. Let us have dot container created. Let us display this guy as a flex container, and let's see. So this guy printed everything in the same row. So let's have the flex direction defined. Flex direction as column. Yeah, so this guy prints it well. Let's have align items as center, and also let us justify the content towards the center. Okay, so now this guy prints it as a triangle. Now this looks a bit ugly right now. Let us also define a row class. Let's say each and every row is of height of some particular height. Let's say height of 50 pixels, let's say, and width also to be 50 pixels. Okay, and we are also going to use this guy as a flex container. Display flex, and same thing here as well. Let us align this guy towards the center. Now we are getting a triangle kind of a structure here. Now let us define the column styling for column. Let's have a padding of 10 pixels. Okay, so this guy prints it like a triangle. Let's have the some kind of a background for our columns. Background to be, let's say, black, or let us better use the color code hash zeros, and color to be white. Okay, perfect. We are getting a height and width. Okay, so now let us have the column height as well, because we are using a padding. Let us have a column height to be 30 pixel. Perfect. And let us have some kind of a visible border around it. So across columns, let us have some kind of a border, 1 pixel, solid, and let us use gray. Perfect. So this guy gives us a triangular structure in our component, and let us try to use it for more rows. Let us say we want to print for 7 rows. We get more rows in a triangular format. So this completes our coding exercise, where we are trying to divide this problem into parts. We first solve the logic using a utility that we are writing, get Pascal's triangle. We solve the logic first, and the logic also we are trying to break it down into parts. We created a skeleton first. We created holes to fill later, and then we focused on the holes to narrow down the problem, and we fixed that problem only. And then we are using that data to show in the row and columns within the component. So this completes our coding exercise. Now before you close this video, I just want to cover an important topic and a follow-up question that could be asked to you once you implement this. So which is basically the time complexity. The interviewer may ask you what is the time complexity of the solution that you have written. Now we are going to cover what is time complexity and how do you compute time complexity for various types of codes in a separate video. But let us have a quick idea about what could be the time complexity of the solution that we have written. So time complexity is always with respect to the amount of data size which is provided to the problem as an input. So we are getting number of rows here as an input. Let us name it n. So n be the number of rows. So for this first loop, we are running this loop for the length of n. Basically I less than rows. Now it doesn't matter that you are skipping some rows here, you are starting with the third row or fourth row, that doesn't matter. For a large data set, doesn't matter. So this guy is going to give you a time complexity of order of n, the order of input size. Similarly, if you look at this part of the logic, this is a nested loop. The first loop you are running for the order of n, and you are running the inner loop for the columns, and columns are also here the order of n only, because the number of columns that you can have in a row is the row number itself. So that is also proportionate to order of n. If you combine the complexity for this nested logic, this is going to run for each and every row and each and every column proportional to the input data size. So this overall time complexity for this particular piece of the logic would be order of n square. Now this guy gave you order of n, now this guy gave you order of n square. The overall time complexity for this entire solution would be order of n square. So remember that such kind of follow-up questions can come, and you should be able to tell the time complexity of the solution that you have written. We saw that in this video, we solved the problem of Pascal's triangle in the order of n square time complexity. So if you have encountered a solution where it can be solved in given lesser time, say order of n, please let me know or point me to that solution in the comments. Also tell me in the comments what all other coding related exercises you are encountering very often during the interviews, and you want me to cover those in such videos. I'll do that. So if you like this video, please leave a like, share with your friends, subscribe to my channel, and I'll see you in the next one. Thank you.